Okay, so here's a little recap on what we've been doing with trigonometry in Year 11 so far. We talked about the fact that we've done SOHCAHTOA for right-angled triangles, and we've looked at angles that would fit inside a triangle. We also then looked at, there's these special triangles that we like to look at, and these are the triangles that you'll find in any geometry set, and they're the set squares. So one of them's got a 30 degree, 60 degree and 90 degree, and the other one's got a 45, 45 and 90 degree. Now the good thing with those is that we realise that we can use these to, let me just get out a drawing tool here. This one here is really helpful for me because I can figure out sine, cos and tan of 30 degrees and 60 degrees just from that triangle. All I've got to realise is that triangle is basically half of an equilateral. You can see the equilateral that it's half of here. Now clearly an equilateral triangle has 60 degrees in each of its angles. So half of that would be 30. So I can say that that one's 30 up there because I've divided my equilateral triangle in two. The most simple sized equilateral triangle I can have, which doesn't end up with fractions for its sides, is one where the side is 2. Why is that a good number? Because I know this side is half of it, which is 1. That's why I use 2 to start with, because that avoids me going into fractions. Now if that side, the hypotenuse is 2 and the short side is 1, the other short side, according to Pythagoras, will be root 3. And here's the calculation over here for how you do it. So we can come up with the 2, 1 root 3 triangle, and that's the one that we're going to use anytime I want sine, cos or tan of 30 degrees and 60 degrees. Now, the other one that's of interest to us is this one here. That's the other set square. Now, when you look at that one, you recognise that it's an isosceles triangle because those sides are equal. The most simple way I can give values to that triangle is to call the equal sides with a value of 1. So if this one's 1 and this one's 1 here, then Pythagoras has something to say about what this one is. And I can find that over here. 1 squared plus 1 squared equals root 2, the square root of it anyway. And that's what we need for the hypotenuse. Take a minute to look at that and make sure you're happy with what I've done there.